So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of 3D trigonometry and Pythagoras. Now in this video we'll just go a quick overview about what it is and how to approach these questions in an exam before going through some past exam questions. Now a copy of the questions that we go through are available for you to download and have an attempt at simply by clicking on the link in the description. Now before we get started working through some practice questions, let's just recap the topic of 3D Pythagoras and trigonometry. Now often when you're asked to find the length or an angle inside a 3D shape, that you can expect it to be a 3D trigonometry and or Pythagoras question. Now the first step in answering these questions is to establish what you've been asked to find and then connect that to a right angle triangle, which you may need to draw yourself. So that triangle might not be drawn for you, so you just need to take the extra steps to then find that right angle triangle. Now the next step is then, depending on whether it's a side or an angle that you want to find, work out the components to enable you to use Pythagoras or trigonometry to gain the overall answer. Now that might seem like a big waffle, but again, when you put it in the context of a question or the method of answering a question, hopefully that will hopefully make a bit more sense. Now the key thing to remember with regards to 3D trig and Pythagoras is that there are no new formulas that you need to know. Yes, the questions can look more complicated, but basically 3D trigonometry and Pythagoras questions are what I like to call two-step trigonometry and Pythagoras questions. So it just means that you have to do some legwork to find the bits that you need to then be able to comfortably answer the question. Now to find the sides, the key thing to do is to find the side on a right angle triangle. You need either one of two things. You either need to know the two other sides of that right angle triangle, so then you can then use Pythagoras, or you need to know one other side and an interior angle which isn't the 90-degree angle and use trigonometry. Now if you're asked to find an angle or on the right angle triangle, you will need to find the two lengths of the triangle and then use trigonometry. Now to find these components you may need to use Pythagoras and trigonometry again or for the first time to get those. And I always say the key tip to make 3D Pythagoras and trigonometry questions is to draw lines, highlight angles, look out for right angle triangles and use colour and draw separate triangles, which I'll do in great effect when we go through some past exam questions. Now you may be asking, well, I've been told that we can't use colour in exams. Well, that is true, but the key thing is that anything that's not written in black or blue pen is susceptible not to be marked. However, if it helps you to use colours to find the components that you're then showing you're working out in black ink or blue ink, then that's going to be absolutely fine. Just remember that anything that's not written in blue or black, again, there's a chance it might not be marked. So using colours to highlight keywords or to highlight key properties of triangles is absolutely fine. So let's get started on question 1. So question 1 says, work out the length of the diagonal AB in the cuboid with dimensions of 5 centimeters, 12 centimeters and 15 centimeters. So again, the first thing I want to do is first of all highlight what it is that I'm actually wanting to work out. So I want to work out the length of this pink line. Now I know that in exams you're encouraged not to use colours because obviously that doesn't scan up on the computers when they're marking your papers, but anything that is coloured that you can use, it's not illegal to use colours in your exams, but what you do need to remember is that anything that's not written in black or blue may not be marked. So again, use colours to help you, but make sure you are showing full working out as to what it is you're doing. So looking at this, I've highlighted AB. So what I want to do is I want to find a right angle triangle that uses that pink line. So I'm going to draw a right angle triangle. I'm going to draw this one here. So what I've got is I've got my pink line and I've got these two blue lines. Now looking at the diagram, I know one of the lengths, which is 5 centimeters, and the pink line is what I'm looking, so I'm just going to call that X. So what I need to do is I need to work out what this green line is going to be. Now if I knew that, I can then use Pythagoras to work out what that is. Now because X has already been used, I'm going to use a different letter, so I'm going to go for Y. So what I need to do is I need to find Y first. I'm going to call this Y. Now looking at Y, I can see another right angle triangle that Y is connected to, and that is this triangle here. And I'm going to try not to use the same colour. So let's go for purple. So if I take this base triangle out, which uses y, then y is the diagonal. And looking at the diagram, this length here is going to be 15 and this length here is going to be 12. So all I then need to use is use Pythagoras to work out what y is. So from this I get y squared equals 12 squared plus 15 squared. So then y squared equals, if I type that straight into my calculator, I get an answer of 369. So y equals the square root of 369. Now I can either use y equals 369 in its exact form, or I can write out what it is as a decimal, which if I type into my calculator is 19.2. So that's going to be 19.209. Now if you're going around and use the decimal number, always add on a few numbers after the decimal point just to help with the accuracy of your answer. So where possible, use the exact answer, so you could use it in terms of third form, but if you are going to write a decimal because you feel more comfortable using numbers, then make sure that if you're going to round your answer to one decimal place, maybe go 2 or 3 decimal places with the numbers you're using in your working out. So I know that y is root 369. So then from this triangle here, I can use Pythagoras again. So I've got x squared equals 5 squared plus 369, or root of 369 squared. So x squared equals 25 plus 369. So x equals 369 plus 25, which is 394. So therefore x equals the square root of 394. That's the exact answer, or I can work that out, which gives me an answer of 19.8, and that's in centimetres to 1 decimal place. So moving on to question 2, it says here is a cube with a length of x centimetres. One diagonal is shown. Circle the length in centimetres of the diagonal for 1 mark. Now I personally think this question is worth a lot of marks, but if you've had practice of working with 3D Pythagoras and trigonometry, or Pythagoras I should say in this question, then it should be relatively quickly, but I think this question is massively undermarked. So let's first of all highlight the length that we're wanting, which is this blue line, and I'm going to start by calling that x. So if I then draw a right angled triangle that connects x, I get this triangle here. Now I know that the height of that is x, but I don't know what this length here is going to be. So if I start by drawing that triangle out, let me just use the colours that I've used, like so. This is what I want, which actually I shouldn't call x, let's call that y. This is x, and this orange line is something that I need to work out. Now to work with that orange line, if I draw a right angle triangle that uses that orange line, I get this purple triangle, and this is going to be x and this is going to be x because they're both lengths on the cube. So then drawing this out, to work out what that orange line is going to be, I've got x and I've got x. And again, let's just call this orange line z. So z squared equals x squared plus x squared. So therefore z squared equals 2x squared. Then, now I'm going to leave that as it is. So let's just call that orange line, get rid of that question mark and call that z. So then using this triangle, and let me just take that over here, then we know that y squared equals x squared plus z squared. Well, we know that z squared equals 2x squared, so y squared equals x squared plus 2x squared. So y squared equals 3x squared. So then to work out y, I need to square root both those two things, so it becomes the square root of 3 times the square root of x squared, which I can then simplify as root 3 times x. So the correct answer is going to be our first option. Moving on to question 3, it says that a tower is located at the corner B of a rectangular field ABCD. AB is 80 metres, AD is 120 metres, and the tower is 20 metres tall. Calculate the length of DE. So it's that dotted line that I need to work out. So let's start by just connecting that line up. Now the next thing for me then to do is to draw a right angle triangle that's connected to that purple line, which is there. And let's start by labelling the bits that I've been given in terms of the question. So I know this is 20, this is 100, that should be 80 rather. And the tower is 20. So then if I take, so in order to find that purple line, I need to know the two lengths of that triangle. So I know that this is 20. This is what I'm wanting to work out, which I was going to call x. And this line here is the question mark. Now if I draw a right angle triangle that uses that length that I need to know and take this triangle out, that this is B, this is D, and that's D and that's A rather. And that's 80, that's 120, and this is what I wanted to find, which I was going to call y. So I know that y squared equals 80 squared plus 120 squared. So y squared equals, if I type that into my calculator, I get an answer of 20,800. So y equals the square root of that, which is 40 root 13. So then what I can then do is go back to my original triangle and then label this as 40 root 13. And then I'm going to use Pythagoras on this particular triangle to work out what x is. So here I've got x squared equals 20 squared plus 40 root 13. Again, if you want to use the decimal version of that, that's absolutely fine. If I type that all into my calculator, I get an answer of 21200. So therefore x equals the square root of that, which gives me an answer of 145.6, and that's in meters, and that's to 1 decimal place. Then moving on to question 4. So this one involves an angle, so I'm guessing I'm going to be using trig on this one. It says the length of an internal diagonal of a cuboid is 18 centimeters. The diagonal makes an angle of 26 degrees with the base. The area of the base is 160 centimeters square. Work out the volume of the cuboid. Now the volume of the cuboid is, the formula we use is the cross section area multiplied by the length. Now the cross-sectional area is the base, so it tells us that the area of the base is 160. So what I need to do is I need to work out the length. This length here is what I'm wanting to work out. So let's have a look at what we know. So we know it tells us that the length of the diagonal is 18 centimeters. So this is 18. So if I take that triangle out, and this is what I'm needing to find. If I draw that triangle out just outside of the shape, I get x, I get 18, and I've got 26. So because this involves, I'm working outside and it involves an angle, I'm going to be using trig. So labeling this up, I'm looking for which trig ratio uses O and H, and that's going to be sine. So I've got sine 26 equals the opposite over the hypotenuse. So x equals 18 sine 26. Now if I type that into my calculator, 18 sine 26, I get an answer of 7.890 and then a few decimal places after. So this length then is 7.890. So then to work out the volume, I've just got to multiply 160 times 7.890, and which is still on my calculator. So we just times that by 160. I get an answer of 1,262.5, and that's to one decimal place. Moving on to question 5, it says the diagram shows a pyramid. The base of the pyramid ABCD is a square. AB is 6 centimeters. The point P is 12 centimeters vertically above the base. Work out the size of angle PAC. So let's first of all work out the angle we need to find. So I'm going from P to A to C. So what I'm wanting to do is work out this angle here. Now if I draw a right angle triangle that connects those, I get this. And this is what I'm going to need to find, which I'm just going to call X. Now then, filling in the information that I've been given, well, I know that AB is 6 centimeters. So this is going to be 6, that's going to be 6, that's going to be 6. And I know that this length here is 12. Now to find a missing side, now in terms of what is 6, let me just correct that because that's a little bit deceiving. It's this length here that is 6. So what I need to do is I need to find another side of that triangle that I've drawn, this green triangle. Let me just draw out again. Because in order to find an angle, I need to know two sides. So I know this is 12, so I either need to find the hypotenuse or the adjacent of that. Now, if I can then work out what A to C is, because if I take this right angle triangle out, and that's A, C and D. Now what's also good practice is to label the points. So A, P, and let's just call this one M. Now A to M is half of A to C. So if I can find out what A to C is going to be, it's going to make my life a whole lot easier. Now looking at that diagram, this is 6, this is 6, and this I'm just going to call Y. So y squared equals 6 squared plus 6 squared. So y squared equals 72. So y equals the square root of 72. Now that means then that AC equals root 72. So therefore A to M is going to be root 72 divided by 2. Now this is what I'm now going to use here. Now I could work that as a decimal, it's entirely up to you. So if I then work with this triangle here, let's move that down. And this is what I'm wanting to work out, I'm just going to call X. This is 12, and this, if I work out what root 72 is divided by 2, gives me an answer of 4.2426. So then using trigonometry, I've got the opposite and I've got the adjacent, so I'm going to be using tan. So tan x equals 12 over 4.2426. So then x equals the inverse tan of 12 over 4.2426. And then if I type that all into my calculator, I've still got that 4.246 number in my calculator. So inverse tan 12 divided by the ands, and I get an answer of 70.5 degrees, and that's to one decimal place. Moving on to question 6, it says, and just try and get that a little bit better on the screen. So it says Jamie walks in a straight line from A to D. Work out the size of angle DAC. Okay, so DAC goes from D to A to C. So what I'm wanting to do is I'm wanting to work out what this length here is. So it's this angle that I'm wanting to work out. Which looks pretty small, but there you go. Now in order to work that length out, so let me just draw that again. So it's clearly to see the right angle triangle. This is X, that's A, that's D, and that's C. Now looking at the diagram, I need to work out what AD is, DC is, and AC is. Well, only two of those lengths to find out what X is. So let's go about working with each of these. Well, if I work out D to C, which is the orange line, so if I take this orange triangle out, then this angle here is 5, this is 450, and this is DC, which I'm just going to call E. I'm just going to call it a random letter, E. So then using this, I can use tan to work out what E is. So I've got tan of 5 equals E over 450. So E equals tan 5 multiplied by 450. Actually, let me just do that the other way around, so I'm not making an error on my calculator. So 450 times tan 5. And if I type that all into my calculator, 450 times tan 5, I get an answer of E equals 39.369, and it's a number that carries on from there. So E is DC, so I can write this as 39.370. Okay, and then the next thing I then need to find is A to C. So looking at A to C, that's this blue line. So if I draw another right angle triangle, and this is A, C, and B, that this is 450 and this is 300. So let's just call this side here F. So then using Pythagoras, I've got F squared equals 450 squared plus 300 squared. So F squared equals 450 squared plus 300 squared equals 292,500. And so F equals square root of that answer, which is 540.833. So going back to the original triangle, I can then label this as 540.83, and we'll round it up to 3 decimal places, just like we did. So then if I then take this triangle and draw that out separately, so this is the angle that I'm trying to find. This length here is 540.833. Height was 39.37. So then using tan, I get tan x equals 39.370 over 540.833. Now rounding with regards to in between questions, it's your personal choice. If you want to use the exact answer, that's entirely up to you. So for example, I could, rather than using 39.370, I could have used 450 tan 5, and instead of using 540, I could have just used the square root of 292,500. That'll give me the exact answers. Or ultimately, what I would strongly recommend that you do, that if you think about how you're going to give your final answer, so I'm going to round my final answer and give it as 1 decimal place, then I may use numbers in the working out to 2 decimal places. So from this we get x equals the inverse tan of 39.370 divided by 540.833, in which I get a tan value, an x value of 4.2 degrees, and that's to 1 decimal place. So then moving on to question 7, it says rectangle ABCD is a horizontal base to the triangular prism of ABCDEF. A to E is equal to B to E. E is vertically above M and midpoint of AB, and AB is equal 16 centimeters, AE is 17 centimeters, and BC is 30 centimeters. And the question for 7a says show that EM equals 15 centimeters. So EM is this length here. Now if I start by filling in the information, so A to B is 16, so all of this is 16, and that means that as M is the midpoint, that this here is going to be 8 and this here is going to be 8. A to E is 17 centimeters, so this length here is 17, and B to C is 30 centimeters. So that's what I know. So looking at E to M, if I take this triangle out, then if you can't see it, let me just draw it again. So that's EA, that's E, that's M, and it's a right angle triangle. This length here is 8, that's 17, and this is what I wanted to work out. So as you can see, it's going to be Pythagoras. So here I've got x squared equals 17 squared minus 8 squared. So x squared equals 17 squared minus 8 squared, which is 225. And therefore x equals the square root of 225, which is 15 centimeters. So E to M equals 15 centimeters. And again, you could write E to M equals x at the start. Moving on to question 7b, it says work out the size of angle ECM. So let's have a look at what it's actually wanted. So E to C to M is this angle here, which we'll call theta. Now looking at that right angle triangle, so let's use blue, as it seems quite a dominant colour in what I've done so far. So if I take this triangle out here, then it's theta, which is what I'm wanting. That's C, that's M, and that's E. Well, I know what E to M is because that's 15 centimeters. So what I need to do then is either work out E to C or M to C. Now looking at the base of that, if I take this triangle out here, and again let me use, what colour have I used? Go for pink. That's going to be too, let's just use the highlighter. So if I take this triangle here of MBC, and just label that, so that's CMB. Then looking at the dimensions, this is 30 and this is 8. So to work out C to M, I'm going to just label that as Y. So Y squared equals 30 squared plus 8 squared. So Y squared equals, I'll just type that into my calculator, 30 squared plus 8 squared gives me 964. So Y equals the square root of 964, which gives me an answer of 31.048. So this length here is 31.048. So then taking this triangle, and let me just put that over here, in which this is 15, this is 31.048, and theta is what I'm wanting. So again, I'm going to use tan. So I've got tan theta equals 15 over 31.048. So theta equals the inverse tan of 15 over 31.048. So then from this, I get a theta value of, and I've just dragged that down, inverse tan 15 divided by 31.048. I get an answer of 25.8 degrees, and that's to 1 decimal place. And that concludes this 3D Pythagoras and Trig topic test.